Hi everyone. SQL is the most widely used database language. If your job requires interacting with databases, a good working knowledge of SQL is important. Each time you select a contact on your phone book, you are using a database. Each time you use Google search to find something, you are using a database. So, what is a database? It's a collection of data stored in some organized fashion. A database can contain multiple tables, each storing a structured list of data about a specific subject. For example, we will not store customers and orders in one table, but we will create two separate tables, one for each list. Tables have characteristics and properties that define how data is stored in them. This set of information that describes a table is known as a schema. And schemas are used to describe specific tables within a database. A column represents a single field in a table, and all tables are made up of one or more columns. Each row represents a record in a table. Every row in a table should have some column or set of columns that uniquely identifies it. For example, in the customer table, customer ID can be used to identify every row in the table. SQL or SQL is an abbreviation for Structured Query Language, which is designed specifically for communicating with databases. In the subsequent slides, we will see some key SQL statements that will help you in confidently working with relational databases. SQL statements are made up of plain English terms which are called keywords. Every SQL statement is made up of one or more keywords. The SQL statement that everyone probably uses the most is the select statement. Its purpose is to retrieve information from one or more tables. To use select to retrieve table data, you must at a minimum specify two pieces of information. Number one, what you want to select, and number two, from where you want to select it. Let's look at an example. I'll use the sample databases available in dbeaver. Here we have three tables, track, album, and artist. And we want to select all columns from the album table. For this, we will write the statement select star or asterisk from album. And we can retrieve all columns and rows from this table. Now, if we are only interested in selecting a single column from the table, for example, if we want to select the title column from the album table, we can write the expression select title from album, and that will only retrieve all the row entries for the title column. Now we can select more than one column from the table. For example, if we want to select the title and artist ID columns from the album table, we can write the expression select title and a comma, then artist ID from album. And that will retrieve all the row entries for the title and the artist ID column from the album table. Now, what if you don't want to see results for every row in the table and you are only interested in seeing the top few rows? You can use the limit clause, and now we can retrieve only the first 5 rows in the table. Now, what if you want to sort the results by artist ID in ascending order? You can use select asterisk from album followed by an order by clause on artist ID column. And now we can see the rows are sorted by the column artist ID in ascending order. Now, what if you don't want to sort the results in ascending order, but you want the results in descending order? You can use select asterisk from album followed by an order by clause on artist ID, the same as before, and then we specify the keyword des, which is for descending order. And now we can see the rows are sorted by the column artist ID in descending order. Now database tables usually contain large amounts of data, and we seldom need to retrieve all the rows in a table. Retrieving just the data you want involves specifying a search criteria, also known as a filter condition. Now let's say we are only interested to see the albums for artists with ID less than 5. For this, we can use the expression select asterisk from album followed by a where clause with filter condition, that is artist ID must be less than 5. And we can see the information only for the specified filter condition, that is all artist IDs must be less than 5. Now what if we are only interested in a range of artist IDs? We can use the expression select asterisk from album followed by a where clause, and we use the operator between to select the range of values. Here we are selecting the values between 4 and 10, and we can see the information only for the specified criterion. Now what if we are only interested in all titles from album table that start with letter L? For this we can use the expression select asterisk from album followed by a where clause on title, and then we use the like operator with the percent sign, which is a wildcard after letter L. And we can see in the retrieved information that all titles start with letter L. Similarly, there are other wildcards like underscore and square brackets that we can use. Now, what if we are interested in album titles but with artist name? We can use the expression select, and then we use two pipes to concatenate title from album table and name from artist table. Here we rename column as title artist. Here we are using aliases, which are an alternate name for a field or value and are assigned with the as keyword. Then we are doing left join on artist ID field, and we can see the name of the column has changed and the row values are formatted as we wanted. Now, what if we wanted to apply some text manipulation on titles? For example, we wanted to see the titles in uppercase letters. In this case, we can use the expression select and a text manipulation function, upper in this case, on title from album table. And we can see that all the titles are in uppercase letters. Similarly, we can apply other text manipulation functions like converting to lower cases, returning the length of the string, and so on. It is often necessary to summarize data without actually retrieving it all, and SQL provides special functions for this purpose. We will use aggregate functions which operate on a set of rows to calculate and return a single value. Similarly, there are other aggregate functions like average, sum, min, and max, which can be used when required to summarize the data. Here, for example, we want to determine the total number of artists in the artist table. We can use select, and then we could say count, and in parentheses we could say asterisk, and then we are using alias as total artists from artist, and we have 275 artists in the artist table. In the last slide, we saw aggregate functions providing a single value for the data. Now, what if we want to see these summaries based on the data groups in the table? For example, what if we are interested in knowing number of albums for each artist? Then we can group the data and then apply the aggregate functions. Here we want to determine the total number of albums by each artist and then select 5 artists with most number of albums. We use select artist ID and then count the number of rows and use alias for this column as total albums. Then we use group by artist ID and then order by total album to sort them in descending order. And then we pick the top 5 using the limit class. Now we can also rephrase the previous task as select artist IDs with more than 10 albums. For this, we use the same statement as before, except we replace order by with having keyword and specify the condition that is total albums must be greater than 10. And we can see only 3 artists have more than 10 albums. So far, we have seen simple SQL queries. Now, SQL also enables us to create subqueries, which are queries that are embedded into other queries. For example, what if we want to know the album titles for the two artists Guns N' Roses and Led Zeppelin? We can use this expression where we select all columns from album, where artist ID, then we use in keyword, and then we write another query in parentheses where select artist ID from the artist table, where artist name is in from this list of subset of artist names. Subqueries are always processed starting with the innermost select statement and working outward. Now we can see the results for only these two specified artists. Another way to use subqueries is in creating calculated fields. Let's revisit another problem where we were interested in the total number of albums by each artist and more specifically the top 5 artists with most number of albums. And in the previous example we used grouping. Here we will use subqueries as calculated fields. Here we start with select artist ID, name from artist table and then get the calculated field which is the number of albums using the album table and where clause. Then we sort in descending order and choose the first 5 results same as before. And we can confirm that we got the same results as before with the grouping method. One of SQL's most powerful features is the capability to join tables on the fly within data retrieval queries. Joins are one of the most important operations that you can perform using SQL Select. And a good understanding of joins and join syntax is an extremely important part of learning SQL. Here we see 4 different types of joins. Starting from left, we have left join, right join, inner join, and full join. Creating a join is very simple, and we will see in the coming slides how we can combine rows from multiple tables based on how they are related to each other. Let's look at what inner join is, which lets us select records that have matching values in both tables. We can use the where class to achieve this join, and we can also use inner join class to find the matching records in both tables. Here we are joining based on artist ID field. Now we can use except operator to find the difference between two datasets from both select statements. And we can see there is nothing to display since both statements produce the same dataset. The left join lets us select all records from the left table and the matching values from the right table. Here we can use left join clause on artist ID field from both tables. Now the right join is very similar to left join. It lets us select all records from the right table and the matching values from the left table. Here we can use right join clause on artist ID field from both tables. Now we can see there were some artists in the artist table who had no albums in the album table, and for those we see null values. The full join lets us select all records when there is a match in left or write tables. Here we can use full outer join clause on artist ID field from both tables, and we can get our records from both tables. Most SQL queries contain a single select statement that returns data from one or more tables. SQL also enables you to perform multiple queries and return results as a single query result set. These combined queries are usually known as compound queries. For example, here we combine two select statements using the union keyword. Union instructs to execute both select statements and combine the output into a single query result set, which we can see in the result table that artist ID only contains number between 4 and 6 and between 8 and 9. Okay, I think we will take a short break here as this was all about the select statements or about retrieving information from one or more tables. As I use the sample databases in dbeaver, you can also pick another database and practice these statements and query the database to retrieve information. Select is undoubtedly the most frequently used SQL statement. In the next part, we will cover other important topics such as how to insert data into tables using insert statement, update and delete data, manage transaction processing, and use cursors. If you liked this video, press the like, share the video, and subscribe to my channel. Thanks for watching and see you in the next video.